In the meantime, we have Johann Kepler, who was not born into a noble family. He was born into poverty. His father was a soldier and killed when he was very young, and he was stuck with his mother, who by all means treated him very, it would be child abuse in this day and age. She was very unkind to him. He was, because they were poor, there were not a lot of options, and he was expected to become a clergy, but he managed to become a mathematician instead because he really loved mathematics. He really loved the universe. He loved the motions that he saw out there, and he too did believe in the Copernican theory. And he was prosecuted for that, and he actually was exiled from Germany, where he grew up, because of that belief and because he was a Protestant. And this was during the time of the 30 Years' War. So he did not murder Tycho for his data, but what he did do was steal it. When Tycho died, he left his data to his family, but Johann Kepler stole the data before they got their hands on it, and it's a good thing he did, because that's why we have Kepler's laws of planetary motion, which he derived from Tycho's data. He also wrote a story which is considered to be the very first science fiction book ever, called Somnium. It describes a trip to the moon. And in that book, there is a witch who people thought that he had based that witch, that character, on his mother, because she lived by herself in a little shack in the woods, and she gathered herbs and made medicinal things and potions and stuff. So they arrested her, and she came very close to being burned at the stake. Kepler managed to save her. And Kepler, the man who who developed the harmony of the spheres and the laws of planetary motion, died broke and poor and writing horoscopes for a living, which is really not a very magnanimous ending for someone of that intellect. Remember, this was the point in time. What makes this period of time so fascinating is this is when alchemy was starting to turn into chemistry, and astrology was starting to turn into astronomy. And it was actually Tycho and Kepler, and each of them discovering their own supernova event and studying that actually started the science of astronomy, and it started separating from astrology and horoscopes. Then we have John Flamsteed. John Flamsteed was the first royal astronomer of Great Britain. In fact, they built the Greenwich Observatory just for John Flamsteed. And when he was doing, and he did a lot of observations, he was known for not being exactly precise with his observations. He made a lot of errors. And after he died, they were taking all of his observations from his observational journal and making a star atlas, a star catalog out of that. And when they did, they had noticed in this one on this one page that he made a little note that he had seen a star in a place he had never seen a star before, and he had a little question mark about it. So everybody looked, and they said, well, we don't see anything there, so this was probably something he thought he saw and he didn't, and they left it out of the star catalogs. And then later on, it was decided that, maybe he actually did see Cas A, when people started to wonder why nobody saw that event. So if John Flamsteed did see Cas A, then he recorded that in the year of 1680. But did he? Well, as I was looking around to see if there was any other possible dates for Cas A that anybody else had come across or developed or thought about, I came across Martin Lunn, who was the astronomer at the Yorkshire Museum in the UK. He was working with a young woman from the United States, and they had been going through the archives downstairs, and they had discovered bits and fragments of medieval poetry written in ancient Latin, ancient Hebrew, various and sundry things. Because remember, back in the 1600s, there were lots of wars going on. And that's when knowledge was passed down by troubadours with song. And books were compiled in monasteries and abbeys So, and they were written in that poetic form. So, and then of course, as the wars developed and the monasteries and the abbeys were burned and books were burned and manuscripts were burned, it did a lot of disruption. But they have found fragments of poetry that mention some celestial event that took place, some bright object in the sky on King David II's birthday. So, Martin Lund and his assistant thought, I wonder if that could be Cassia. If so, Cassia event would have been visible on May 29th, 1630. I emailed to Martin, I emailed him a few weeks ago and asked him if he had come up with anything further, because they were trying to find additional funding to carry on the research about delving into this Cassia mystery. And he said they were going to start the procedure again for financing, because he had come across another fragment of poetry that actually said recent new star in Cassiopeia. Okay, that one was in 1633. Now, the former reference was just something that appeared on King David II's birthday. This one actually pinpoints it in the Cassiopeia constellation where Cassia is located. So, we have another possible date. So, in the background introduction segment summarizing the evidence for Cassia, we have the medieval poetry, 1630, 1633. We have John Flamsteed, 1680. We have the ice core data. Now, there are 2 or 3 possibilities. I will not go into that at the moment. The ice core data, though, does have supporting evidence. There is evidence also of supernovas, of these particular anomalous spikes in Antarctica, in both the South Pole and at Vostok. Now, the resolution of those ice cores is nowhere near the high resolution of the Greenland ice sheet ice core, the JISP-2 core, but you can still see anomalies that are in approximately the correct locations, so that might be collaborating evidence. And then, of course, we have mathematical extrapolation, because you can measure the expansion rate of the Cassia supernova remnant and extrapolate that backwards to determine at what date that event most probably occurred. So here is what the students actually do with this investigation. There is a 10-page handout. It gives them all the information they do to perform this investigation. So it is up to you as to, are you going to pass out the entire handout? Are you going to pass out just the data tables from it, because those are available for download for a separate PDF if you can't download that much paper? You can get this ice core strip printed out. It works 20 by 20, but it really works the best if it's at least 24 by 24 inches, the entire sheet, which represents one full ice core strip. It has been divided into 4 parts, each one approximately 2,000 samples worth of data, starting at 1992 at the top and going down to 1562 at the bottom. And however many sheets of those that you need, you'd only have to print out one answer key one. So the students they have a brief description of ice core layers, and the fact that there is background annual cycles that the nitrate and conductivity goes up and down. A lot of that is related to phytoplankton in the oceans in the summer producing more nitrates. On this particular, here's an example. The conductivity is in green, and you can kind of see the annual cycles going up and down. Here's the nitrate. You can kind of see annual cycles. Of course, they're not symmetrical, because no year is exactly like another year, but every now and then in the record you will see an anomaly, a spike, some discrepant event other than the usual normal terrestrial events that produce nitrates happened to elevate the nitrate conductivity. And Team 1 has samples 0 through 2000 basically. They have the youngest core, and then down through Team 4, which has the oldest one. It says 7,800 here, but actually that other data was added to it, so it goes down to the full depth of the ice core sample, about 8,000 samples.